Because we have some from you, I guess.
It's only three. Only three.
Only three. Wow, that's
Well,
not that much.
You know what they say? One pull request a day keeps the doctor away or something. I don't know.
Never heard that one before, but sounds good.
Yeah. So which one is the most urgent one?
I guess the C point one.
Yeah. What's the status of that one?
And they're all finished.
Okay, because I saw that you have like some you added some commits there.
Yeah, about 10 of them just this morning. Yes. I wanted to do something, but it changes a lot of the residuals to do it, and it would be too much trouble to update all of them. So
yeah, but would it like help with something? I mean,
not right now. It's just that so C point stores the neighbors of each node, right?
Yeah.
And at the moment it's just a list of indices, and it's not sorted. And if it was sorted, if we wanted to look through that list, we could use binary searches or something, but it's not something we do at the moment. So in the future, maybe we can do it, but to do it now, we need to update many test cases, and feels like too much trouble.
Okay, yeah, that makes sense then. I mean, is there something special that needs some explanation?
Where in the
C points? Yeah.
I don't think so.
So in the end, you did the same that you already did with the solver or with the variables, right?
Yeah, exactly. It's the same storage class. Yeah.
Does it have some performance improvement?
Not as large as the one with C variable, but yeah, it's a bit faster. Yeah.
Probably the pre-processing is a little bit faster, right? As you already mentioned.
Yeah, but the pre-processing was faster mostly because of the algorithmic changes that I put in the other pull request.
Oh, okay. Okay.
Just replacing some maps with unordered maps and small optimizations like that.
Yeah, well, I mean, then I would say this one is good to go. I mean, I have no further comments.
Yeah, I left a question for Edwin 2 weeks ago, but he didn't say anything. So.
Okay, what was the question? Let me see.
I just asked him if all the types of mesh format were covered by the regression test, because I think this change only affects the DG solver during reading the mesh, and then he doesn't use C point to store the data. He copies all of that somewhere else. So basically, I just want if this causes any problem to the DG solver, it will only be during reading the mesh.
Oh, okay. So yeah, and you are afraid that it breaks something that is not covered.
Yeah, it's only 3 possibilities, I think. Correct. So, but
yeah, I don't know. Well, I think if it's not in the regression test, then what can we do, right? I mean,
yeah, exactly. I mean, it shouldn't break. It's very it's very straightforward. The only thing he needs is the coordinates and the global index, and so it's
Yeah. I mean, we can merge it if you want.
Yeah, let's go then.
Yeah, we do a live merge of the pull request. Approve.
Hey guys, sorry I'm late. I'm here.
Hey Tom.
Hey Tom.
Do you have any comments for the pull request with the contiguous storage from Pedro?
I left the one comment about the sorting. I don't know if it's in the end. What did you find?
So I tried to not sort them before the RCM ordering, to try and get the same RCM ordering, and then sort only the results, to see if that would give the benefit of having the sorted points without changing all the residuals, basically. But it still changes all the residuals, so I just gave up on the idea for now.
Yeah, I mean, I was there a lot to be gained other than just knowing the points are in order for other purposes?
No, just if in the future we need to implement something that requires looking through that list or something, it would be more efficient if they were sorted and we could do binary search or whatever. But at the moment, there's nothing really relying on. There's nothing that would stand to gain a lot from doing it.
Yeah. I think it's fine. I mean, it would be nice to have, but I don't think it. Maybe there'll be a reason in the future to do it, and then we can just do it at that point. But that was I looked through it quickly. That was the only comment I left on it, but otherwise, I think it was fine for me.
Because then I can click on the merge pull request button.
Live for the world to see.
Yeah, I mean, makes sense, right? Since you're already here, nobody has a comment. Good.
Oh, I don't know if you saw, Tom, but I mentioned on the null pointer pull request that the conflicts are already solved in a different branch, so you can just merge that onto yours and it should be fine.
Okay, sounds good. Yeah, I'll do that today then. Now that this one's in. But you have another one open, so it's okay to merge the null pointer stuff after 966, the one we just merged. It's not going to cause any problems for your other ones.
No, the other one's already. Well, one is very small. The one with outputting the having the linear solver statistics available for discrete adjoint solvers. That one is very small. It's completely independent from everything. And the continuation of the hybrid parallel work already contains everything.
Okay, cool. Sounds good. Then I'll do a quick update in a little bit, or maybe I can try to do it in the background here while we're talking.
Yeah. So I don't know whether you saw it, but I made like a small proposal yesterday in this one new draft pull request there.
Yep.
I mean, it's just a it's really a quick draft. Yeah. So also the names are not final and stuff like that. But what I noticed when I was working on the output stuff is that we have like a lot of things scattered around the code, right? A lot of things that actually are there for the same purpose, but I mean, they do the same task. So for example, this what I have there, the example is the fixed CL computation. Right, so we have things for that in the solver. There are things in the output. There are things in the driver, and it's really hard to like get an overview on what is actually done there, right? And what routines are used together. And yeah, so I find it very complicated. So I thought about like a way to put all these things together in one class. And I thought about like some small modules that can like then define some routines that are called as special points in the code, right? But that would give the advantage that we have everything that belongs to one task is really together in one class. Yeah, I don't know whether that makes sense or not, but this is just some idea that I had.
I like it. I like anything that that helps moving code out of well, it helps moving some code out of the supermassive classes that that we have.
Yeah, exactly. That is the idea then in the end, right?
Either
and also that you can
functions
easily
or just small
deactivate
objects.
like these things, right? Because with that, we only have like one point where there is the Boolean that checks whether that module should be active or not. And if it's false, then none of these routines of that module are called at all. So the only question is, or the only problem is how to pass like these pointers to that modules, right? I mean, what do you expose to that modules? It's very hard to see or to I don't know. I mean, maybe I can share the screen to like show what I actually mean. Maybe that makes more sense.
Yeah, I think it'd be great if you could walk through it real quick. I'm looking at your code, but you'd explain it better.
Okay, so you
need to explain you need to explain all that templating. Yeah.
Well, I could. I mean, like I'm writing that, it can be also done in a dynamic way. We don't have to use templates, but I was just curious whether it works and how it works and stuff like that. So it's also like the general interest in this templating stuff.
Yeah, you're going pretty extreme there. Your two poles and your ellipses.
I relate to that very well, but
yeah, so I can show you maybe the example here. So let me see where you want to start. How was it? Yeah, so the general idea is that we have this modules class here. Yeah, so like for example, this fixed CL module here. I don't know, is it big enough? I don't know. Otherwise, you can like.
It's not very big. No, can you make it just like one page? It looks like it's 2 pages. Yeah, that's better.
Yeah, that's good.
I can make it also. Wait a second. I think you can change it somewhere in unified, right? Yes. Maybe that is better.
Yeah.
Yes. Okay. I mean, so the general idea is that we have this modules class here. So here it's called like solver module, but okay, don't put me down on the names there. It's like that's everything is up for discussion essentially. But the problem with the fixed CL stuff was that we have like all these routines here: the set far field AOA, the set coefficient gradients, fixed CL conversions, monitor CL conversions. They were all scattered throughout the code. Right. So the set far field routine was in the solver. The set coefficient also in the solver. The fixed CL was in the iteration. Monitor CL also in the iteration. And it was very complicated to see what these routines do and where they belong to, or what kind of task they perform. So I put everything in one class here, and this is like this module here. And I mean, more or less, I simply just copy and pasted the set far field AOA stuff and moved some member variables of the solver to that class. But the important thing is here this pre-iteration hook and this post-iteration hook. And these are things that are predefined in certain places of the code. Right, so what I mean with that is, so we are here in the iteration structure in the solve routine. So this is essentially the inner loop of the solver. So we do like the pseudo time steps here. And there's the solver module for each. And this calls these hooks here. So this action pre-iteration hook calls for every module the routine that is defined by overloading the pre-iteration hook routine. And the same goes for the post-iteration hook here. Yeah, the templating is just so that this for each is done at compile time. It's not really performance. For the performance, it doesn't matter. It's just that I thought that templates are cool.
Things like sugar.
Exactly. No, what it also makes it very easy to add the module, because we don't have to use some kind of factory method or add some new and delete stuff, because you can simply just add the class. You see where that was. Yeah, you can just simply add this class here to that list, and that's it. That's all you have to do.
And so where does it get like created and where does it get instantiated and then deleted, or?
That happens
compile
essentially
time.
here.
It generates them all.
Yeah. So So what I do is essentially I create, so this modules pointer here is a shared pointer. Sorry, a unique pointer.
Mm-hmm.
Let me see how I define that. It's here. It's also right here, I think. No. Yeah, it's below that. So the modules pointer is just a unique pointer to the modules, so to that module list here. And it's a global variable at the moment. I mean, you can also put that in the driver or in some other class. I don't know. I thought it makes sense to have it in the global scope, but okay. And in the driver preprocessing, yeah.
Does that mean that I'm just thinking if this is going to be like so for example, you remember that in the option structure, those maps, those static maps, they will be instantiated basically. If they are enabled, they are instantiated in every CPP file that includes those things. Is this going to behave similarly? If it's defined at globally like this, is it going to be?
I thought that it's not happening because I have it here as an extern, right? And it's defined in a CPP file, and the CPP file is only compiled once. You know what I mean?
Yeah. Okay.
But yeah, actually, I think that should not happen. So it should only be there once. Yeah, maybe it would be better to maybe put it in a namespace or something like that, though. That might be something that can be done. Yeah, so at the end of the driver preprocessing, I just create this unique pointer here to like it's allocated, and yeah. So here actually all the modules are instantiated or created. Yeah, so you see that the structure is not very complicated, actually. I mean, I think it's rather simple, apart from the from the templating stuff. The problem is that so this list of modules is a tuple, and in C++11 it's not that easy to loop over the elements of a tuple.
Yeah.
I think with C++14 or 17 they have an easier way.
Oh, you can probably even create arrays or whatever of those things and just do, yeah.
Yeah, maybe you can even do some with the const expression or something like that. I don't know. But I think there is also a routine where you can just simply loop. So like I did here for each routine, I think there is something like that already available in C++14 or 17. But with 11, unfortunately not. So this is why we have to use this recursive template definition here. But the nice thing is also, yeah.
So how many, sorry to interrupt you. How many other different modules do you think we can fit into this framework, or do we need to add more hooks? So I can imagine like one or two other things, like the CFL adaption could probably fit here. I don't know, maybe one or two other things. Have you found others that would fit?
I have not really thought about other things, to be honest. I just needed that because I use this structure a lot in the output, because I have like a lot of output modules. And I thought that might be also useful in general for general modules that do something somewhere. But you're right. I mean, CFL adaptation would be one thing, for example. Yes. I mean.
But what if? How does I didn't look through the code with the fix CFL, but how do you get access to items that are in the solver classes or whatever? Are you passing in pointers to?
Yeah. So classes? Right now, this pre-iteration hook and this post-iteration hook, they just get these pointers here.
Okay.
Which is a little bit, yeah. I mean, depending on where the hook is, we can of course change the signature, right? I mean, it's a variadic template, so we can just, for every hook, we can have different arguments. Because at some point, you want to pass in the whole solver container or the multi-grid meshes and stuff like that. That, I guess, depends on where that hook actually is defined or called.
I don't know. I think if it gets to the stage where where you start pressing lots of things, I don't know. If you need to pass too much, it's not a module anymore. It's what I'm thinking. It's
yeah.
But I like it. So how is this? This is not used currently in the output, is it? It's for what you're doing with the expression language.
It's in that branch, yes. Yeah. Okay. But there I use it only for the output. But what I thought is, since, for example, this fixed CL module also defines new outputs, so we can also have hooks here that add new output fields, so that you have really everything at one place, everything in one class. That was would be the overall goal then. But the only question is, like you already said, is how to pass this information, or what information should be passed there, because there are so many different pointers that we have. That's the only complicated thing. And if we define that beforehand, then I don't know, it might be also too restrictive for the general application, you know.
Yeah, but for example, in the case of the fixed CL mode, I mean, this kind of pulling out pulling out the fixed CL routines out of CSolver and making this could also be done like as just a class by itself without having anything else, right? And
what do you mean without anything else?
Without the added machinery that you have here to have a pre-iteration and a post-iteration hook and
yes, yeah, of course. I mean, yeah, well, that would be well, and that can actually it would work because I only have these two hooks here which are in the iteration structure.
Yeah.
But once you have like things that are spread also in some other classes, for example, in the output or whatever, then it's complicated. Right? Or for example, some things that do something after a time step or something like that. Right? At the end of every inner iteration, at the end of every time step or whatever. And then it's complicated. But for the fixed CI model, yes, that would probably work also. Yeah.
I think this is a bit of a Spider-Man situation. With great power comes great responsibility, because you can if this having access to everything, to the solver, to the geometry, you can basically do anything you'd like.
Yeah, but you can also do that at the moment. I mean, if you just do it without that framework, then you can still do it, right? I mean, if you implement the routines in the iteration structure now, you have also access to everything.
Yeah, I think my feeling on it is that it's a very nice implementation. I'm wondering, I think we need to balance how much people are going to use it and how complicated it is versus how nice it is. So, I mean, if you can think of many other instances where we would use it, then I say go for it, because the more we use it, the more lines of code you're saving from going into the solver and other places where the hooks are defined. But if it's only for one or two things, the complexity kind of outweighs whether it's worth it.
Yeah, of course. I mean, if it would be only for this fixed CA one here, then of course it makes no sense. So I have to see whether we can fit also other things into that framework.
I mean, I can think of a couple more things. Like I said, the CFL. I mean, I do like the idea a lot of having predefined hooks that do this, so people don't have to clutter the solver and the iteration, etc., with this kind of stuff. I mean, that would be great. But
yeah, that essentially, I mean, that when we have that structure, then we can essentially fix like a lot of these generic routines, right? And make them more static. And maybe there is less hacking or something like that. I don't know. And it makes it very easy to remove it, right? So that's also a big issue, or to disable it.
Yeah, I mean, it would be great for customization. So it'd be nice if we could, when people come along asking, does the code do this or that? We can say, you know what, all you have to do is write a routine in, a little module that calls a pre-iteration hook or whatever. I mean, that would be nice.
The problem that I see, though, is that, I mean, it depends on where we need all these hooks, right? I mean, then you cannot make it 100% general, right? I mean,
well, let's think about that for a second. How many other hooks do you think people would want? So, I mean, what are the other common operations? Before and after an iteration? I mean,
yeah, before and after inner iterations, before and after time steps.
Mm-hmm.
Then yeah, in the output, like I said, there should be some hooks then. I don't know whether that makes sense to have some in the solver itself, so in the solver classes.
Well, as we're moving all the output stuff out of the solvers, hopefully as we go, do we still find there's a lot of custom code? I guess the Euler, the regular compressible and Navi stocks are still pretty, yeah, they're still pretty cluttered. I mean, all the stuff for like engine VCs and things like that.
Yeah, but they could also be all modules essentially. That would really fit perfectly in such a framework, I think. Because most of these things are done in the preprocessing, which means like before an iteration.
Yeah.
And they also define new outputs.
Yeah, so I mean, maybe that's a way to think about this is if you kind of go through the solver again, or go through solver and preprocessing, and maybe some of the other places where you expect this might help, and just make a quick list. If the list grows to like 10 different things you would put in here, then I think it's worth it. So maybe that's a way to help decide.
Yeah, that is a good idea. I can have a look into that. I mean, for example, we also have the arrow elasticity stuff that would also fit perfectly.
Yeah, that's kind of old too. I know that there's one person out in the wild working on that. I've gotten an email about it, but some of these things we should reassess over time if we need to keep. But putting it in a module is nice, because then we could keep it separate and maybe even unit test it or something.
Yeah. Unit testing is always a big problem, because we always pass these just generic pointers. It's very complicated.
Yeah, that was those decisions were made long ago. I don't think that's tough for us to change now. Ideally, we would have done it differently, but it is what it is.
Yeah, but it's a good idea. I mean, I will think about some more stuff that we can put into that framework, to see where we also need like more hooks maybe, and what data we actually have to pass.
Yeah. I mean, just think of it like you would with any API. Like, what are the signatures going to look like? How many of these things would you have? How many other modules do you think you can make? Yeah, I think that's a healthy exercise.
Yeah.
Okay, but we should keep in mind that this gives you the entry points, but I guess what I'm trying to get at, let's not try to twist all the code into into being modules. It's
well, that's probably not possible. Yeah.
Let's try not overfit the module, as it were.
Yeah, I agree with that. I mean, I would think of it as purely a way to declutter. Let's not make, like you say, Pedro, let's not make changes so that other things fit this just because.
I mean, if everything would be like the CL module here, that's that would be perfect.
We could just rewrite all the solvers to be modules. Is that what you're saying, Pedro?
Yeah, that's exactly what I want to do. Yeah.
No, but I mean something like, for example, the elasticity and the gust field computation, all these things. There it is quite clear that they don't belong actually to the solver. And
yeah, I mean, those, if anything, are all almost pure applications. So it's
a lot of the stuff that you see being called a lot of the stuff that you see being called in the pre-processing of the Euler solver, for example. A lot of that is there's the engine properties, power properties.
Yeah, exactly. Yeah.
Some of those could get a little complicated. You will have to check if certain, I guess it's not that bad. You have to check if certain boundary conditions are active and all that kind of stuff, but that's probably pretty easy in the framework you have.
Well, you get the config, and the config has everything, so.
Yep.
Yeah. One other motivation was that I saw when I was working on the output structure is that since I moved already all the aerodynamic coefficient, the computation to the output, the fixed CI module, of course, was not working, or the fixed CI computation was not working anymore because it was pulling all these aerodynamic coefficients from the solver, and the solver has no idea of the output. So I had to move it somewhere,
right,
or I have to move it somewhere outside of the solver. So that was essentially the original idea. Because I don't think that it makes sense to pass the output to the solver, because then we have like this circular dependency.
Oh no, that sounds like a recipe for very nasty things.
Exactly, yeah, that's also what I thought. But this CL computation changes something in the solver based on the aerodynamic coefficients. So and probably the engine computation, for example, is similar. They all monitor something and then they change something in the solver, and or often they change something in the boundary conditions based on some coefficient that is computed on the boundary somewhere or something like that. Yeah. No, but it's a good idea. I mean, like, I can think of more things, and then we can have a look at it again and see whether it makes sense or not.
Yeah, there's another example I can think of. There's another code that used to be used at Stanford for another research project called Joe, which is a RANS code. It's actually a lot like SU2, but it's a cell-centered code. In that framework, they had a lot of shared classes between different solvers. So similar kind of C++ class framework. And one thing they did was every time you wanted to run the solver, I'm not suggesting we do this. So first of all, let me say that, but just an idea of what other people have done. Every time you want to run the solver, you essentially write a custom main that has some hooks in it, like we're talking about here, that will pull in different models and modules for you. So I know that other codes do this. I mean, it is a nice idea to have, predefined hooks that sit in certain places, so you don't have to go dig around. But so it's not a foreign concept. I think we just need to explore whether, how much we can take advantage of it. Yeah, and maybe there are more ideas you come up with of, like you're doing for the output, defining custom outputs. Maybe there are nice ways now with this framework to let people define custom things in the solver even, maybe, is this a way for people to define a custom boundary condition? I don't know. Something like that.
Maybe something that could also fit into that framework, yes. That might be possible. Yeah,
if you can start doing that,
like a hook in the boundary at the boundary condition level in the solver, then yes.
I mean, That's kind of what you should do with the numerics, right?
Yeah, I could do it with numerics, a boundary condition, thermodynamics, or like a state update. Then we could do it in a bunch of places. No, I mean we shouldn't go crazy. That's
because every oh no, I'm not saying that we should make the numerics into modules. I'm saying that the boundary conditions were kind of designed to use the numerics, but a lot of them don't. They all get like a convective and a viscous numerics class,
yeah.
But a lot of them don't do anything with that. They just implement whatever they need to implement right there on the spot.
Mm-hmm.
And then that leads to a lot of that's not very helpful for reusing things. I think I deleted 1,000 lines of code from a few boundary conditions this weekend or something.
Yeah. Yeah, I mean, it's just a thought because we have always had, you guys have probably seen these, but I don't know that anybody's ever used it. A long, long time ago, we put in the templates. So we put in a solver template, like a numerics template, all of these templates, boundary, like a source term template. I don't think anybody's ever used those. I don't know. Maybe they're too hard to use. Maybe it's time to just pull those out and put in some hooks or something and let people define boundary conditions or sources.
Yeah, because these templates are only for creating a new solver, right? If you have the boundary condition. Well, okay.
One or two of them I think are active. Like I think there's a source template that's active, source residual template.
I think the problem is that you have to like add something to like too many different places.
Yeah, I think it's too difficult for, if you have somebody that just wants to quickly do like a custom boundary condition and they know that, they don't want to have to go dig around the whole solver to figure out all this stuff. I mean, they'll never use it. But if we could make that easier, then that could be really interesting.
That's a good point. I will maybe try to think of a way to incorporate the boundary conditions there somehow. Maybe it can be really done with for a custom boundary condition.
Yeah, worth looking at, like I said, but let's just evaluate whether it's going to be easy, and then
I'm scrolling to just Euler solver, and I think you could just grab the code for config set, and what functions that have config set a lot are perfect candidates to be a module, probably because they are using the config itself as the module that they
choose. Exactly. Yeah, it's somehow like a misuse of the config, but just because the config is passed everywhere, it just makes sense to store things in the config.
It's the Spider-Man problem. It's the Spider-Man problem.
Yeah. That's a very good point, and maybe that should be one of the guideline then. A lot of good points. I mean, that makes sense.
On this issue of having to write too much code to implement things. So for example, if you want a new source term or whatever, you need to write the corresponding numerics, and then you need to go to the place where they are called, and you need to pass data into the numerics. And I had an update on my long-running issue with the hybrid parallel and vectorization. And my idea for a refactored numerics classes is that the numerics itself pulls the data it needs. So you call it, It's still virtual. You call it, and the solver simply gives it access to the data. It doesn't need to know. So you move the kind of like the knowledge of what data to use to the numerics, which is what you want to write, instead of having to give methods for get this, set that, before.
But how do you pull the data then? With some get routines in the solver, or do you have direct access?
And the idea is to give it direct access. Yes.
With a friend, friend stuff, or
potentially, yes. Yeah, because to do this, to do the next step of the to do vectorization now, we need get methods that return small arrays, SIMD arrays, instead of just returning scalars or pointers, right? And it's not practical to go and duplicate every existing get in C variable and C point and C edge and so on, and duplicate those to return a different type, to have like a scalar version and a vector version. So my idea is that we have basically just one type for storage right now, like an underlying type, which is like the 2D container. And so only that needs to implement the thing. So you make it you make the numerics a friend class of the variable that it's going to use or whatever. You give it a const reference or a const pointer or whatever. You're not gonna let the numerics write into it, but you just give it read access to whatever you want. And and you don't need to get and set in two different places and so on.
So what you're saying is that if you want to have like a more like a custom boundary condition, then you would create a new numerics class.
Yeah, for example, yeah. Which is kind of that kind of structure is already there, right? Because there's already like there's a convective boundary term and a viscous boundary term, and there's a source. So and if you look, for example, at the compute at the residual loop of the Euler solver. What's that called? Compute source term, set source term.
Source residual.
Source residual. Yeah. You see, like you see this load of if statements: if body force, if rotating frame, if axis symmetric, if gravity, if harmonic balance, if wind gust. And it's all the same pattern. All you want to do is compute residual. But to do that, you first need to know what you need to set into the numerics before you can call that method.
Yeah.
So the idea would be to move that knowledge into the numerics that you actually implement, and then it's just one call that you need to do. You just do compute residual. You don't care what kind of source term you're computing. You're just computing it. It's a design pattern of sorts. It's not reinventing the wheel or anything. It's the visitor pattern. I know. I'll prototype this with for the vectorization, and then.
Yeah, I mean, maybe we can combine somehow both frameworks. I don't know. I mean, maybe there's I don't know. I mean, I will think about more applications. You prototype that, and then let's see. I mean,
Yeah, Pedro, I think that would be nice. It would save a lot of lines of code from the solver for doing all the setting. The only danger I see would be if it becomes a little less clear. It's a little more opaque to the user or developer who's working on the solver what's going on, but that's not such a big deal. It's a lot of times they probably don't want to see it. And if they really care, they would go look at the numerics and work on the numerics anyway.
Yeah, I mean, and it would kind of open up the possibility of having almost just one convective a generalized finite volume solver, right? Because
Yep.
I mean, if we can make the solver more general, of course, that would be would be nice. Yeah. Okay. I think we all follow the same goals here.
yeah, I mean, we all. I listened to this quote in a video the other day, which is the guy was saying, "I hate code. I want to have I want to have the least amount of code possible in the product."
Mm-hmm. Fewer bugs, less to take care of.
Yeah. People pay for features and not for code or whatever, something like that, along those lines.
Yep, I think that's the way to go. If you want one more fun thing we can do, actually there are two things. I just pushed the update to the null pointer thing, but the tests are running. But maybe in the last couple minutes we can talk about a thorny issue that I don't think just the three of us or four of us can decide. But we need to talk about this auto formatting. What do we think?
Make it 80 columns, please.
No 80 columns. We could potentially turn off 80 columns.
Please, no 80 columns. Let's make it, this that we're looking at, like GitHub standards. What is that? 100, 120?
I think at 120.
I don't know. There's,
as far as I can remember.
Yeah, that's probably a one-liner to put in a client format. That's no problem. We could make it a little bit bigger, but more like philosophically. I mean, do we want to? I think the question for me is whether we force people to do this with each commit, or whether we have some kind of a GitHub action that just in the background auto formats everything from time to time.
I mean, I like the idea, like I already wrote in the comment, that like we do it with Ninja. But that, of course, would require that everybody has installed CLang format.
Mm-hmm. Yeah, this is the issue: is if we force it. Well, I mean, people could do it on their own if they want. If we don't force it, we could just ask people to do it if they submit a pull request that has problems, and then they can download Clang format and do it themselves. But
we can also do it before every release. I mean, we're changing the release numbers, the version number anyway. But yeah, I don't know whether that makes sense. But I mean, the question is, for the beginning, is I think how we want to do that. I mean, if we just do it once, then we have, well, these are like a lot of changes, which means like a lot of conflicts, even more than with the white spaces.
Yeah.
But
Yeah, and I don't know if the merge would be so simple, because with the white spaces, if you clean the two sides independently and then you try to merge them, it goes relatively smoothly, right? That's what you and Tulio were trying, right, Tim?
Yeah. That's relatively simple. Yeah, if you do it in the correct order and stuff like that, then it's no problem.
Yeah,
but
auto
as soon as you have
formatting is
line
probably
breaks
a
and
bit
stuff like that,
exactly. Yeah.
that will be very complicated, I think. So
well, yeah. I mean, what we could do is put the nice thing is if we put a .clang format file into the repository and ship and basically make that available to everyone, then it is possible to do it on both sides of any merge. So then everybody just needs to download Clang format, which is, it's one step, but it's easy. And
yeah, maybe the first
we'll
thing
still
to
have
do is
some
to put
conflict.
like the CLang format there. And then we can at least use it for new files. And yeah, and try to ask the people to use it before they open the pull request or something like that.
Yeah, or maybe there's a bot we can get that we can plug into each pull request that will automatically run this on their pull requests. Then just over time, it'll happen automatically, I guess.
Yeah, but where do you apply then so what files do you apply that then to? Just the changes?
I think just the files they're changing, I guess. I think there are bots that'll do this. It'll only look at files that are changed. I need to look around for that. I didn't look for a formatter, but there might be one.
Yeah, but you only have to look at the changes, because if you change like the whole file, then that will be also complicated then.
Yeah. I mean, the good news is once we do it once, this will be a non-issue. So see, this is kind of, even though it's really intrusive, this is why I do like the idea of just forcing it with a pre-commit hook, because people then, they literally have to run the formatter to commit. It's very intrusive, but it would guarantee that any code going in is formatted the same way.
Yeah, and there you can just apply to the changes. I think I saw that not with C++, but with JavaScript, I think.
Yeah, I think that's possible. I think it's only if the file shows up. I think it probably looks over your diff or something and somehow figures that out.
But that would require that everybody, I don't know what happens if you don't have CLang installed or the CLang formatter installed.
Yeah, I think it just blocks your commit. So it's definitely it's not a very nice thing to do.
We can look into that. But maybe the first thing would be to really put the CLang format file. Maybe we can do that like regardless of how we're gonna enforce that.
Yeah, that's easy. So I can do that. I'll just add what do we think? 100, 120?
What other options do we have? There are probably other things that we might have to decide. I'm not in favor of any particular formatting style, but
well, we technically say we use Google, even though we really don't. But that's why I put
because
Google.
It's also taking care of where the star is for the pointer and stuff like that, right?
Mm-hmm.
Or the const or whatever. Like I said, I don't care for what we decide actually. As long as it's consistent, it doesn't matter, I think. So, we can just put the basic one there and then, yeah.
The basic one didn't look too bad, but like in the file on the files I tried it, it didn't look too bad because the things that that were recently refactored were already refactored not to be 200 columns wide, and not to have like a ton of array indexing into the different mesh levels and the different solvers and the different everythings. I think that those are the bits that are going to look, quite rough. Places in C iteration where you have like copies of data down from the fine grid to all the coarse grids, and yeah, those things are not.
By the way, we have to touch like the iteration structure also soon. It's really waiting for a refactoring.
Yeah.
But that's
one at a time.
Exactly. No, then let's put the basic C-lang file there with 120 characters for the column width.
Yeah, I can do that. That's just a one-liner. I can put that in. I could even add it to my open null pointer. Actually, we can do that.
Yeah, I mean, for me that would be fine, and then we can already use it for new files, and gradually make the people aware that they maybe should use that. And whether we do that with a GitHub or a Git hook, let's see. We can just discuss that afterwards, I think.
Yeah, that sounds good. That sounds good. Yeah, I'll add it to the fixed null pointer here in just a minute, maybe when we're off the phone.
Yeah.
And that one's about ready. So any arguments against me merging that here in a few minutes? Once
nope.
test
passes. No, for me it's fine. I mean,
okay. Perfect. Then I'll add that and then merge it when everything passes. Okay, any other topics, guys?
I think we already touched 1 hour. I think that's okay.
I just have a short question, if it's okay.
Yeah,
it's related to the shape optimization script. So when we are doing the mesh deformation on each design iteration, we always take the original mesh as an input. Why is that so? Does anyone know or have an idea? So we don't deform the mesh.
My opinion is because that's what you should do.
But when you are calculating the gradients, you take the deformed mesh of a certain iteration, right?
Yeah, I brought that up. Before.
So that's why I'm wondering.
You take the deformed mesh to evaluate the gradients, mostly because you need the FFD in the deformed configuration.
Mm-hmm.
I think we agreed, right, Tim, that it was a limitation of the system, of the current system.
Yeah, exactly. Yeah. There's no other reason.
Okay.
Ideally, you would do everything from the base, from your initial mesh, and differentiate around that as well. But it's not so simple.
But yeah. I will do it for a try. I mean, just to try to deform the mesh from iteration to iteration, not to consider the initial mesh all the time. I mean, just to see what will happen.
That's I can tell you from my experience with FSI cases that it's not a very good idea, because if you then want to replicate the final deformation you have, you cannot reliably do that without going through all the steps of the optimization. So if you want to give and your last optimization values will be almost zero, right? If you're just applying corrections to the previous mesh progressively, your final design variables will be zero as it converges the optimization, right? So
I didn't get this part.
If you're deforming with respect to the previous iteration every time,
yes,
right? As the optimization converges, the difference between iterations becomes almost zero.
Yes.
So you're applying smaller and smaller steps, smaller and smaller deformations, right? So what the optimizer needs to see is no longer. You need to be converting all the time between what the optimizer needs to see, which is the absolute variables with respect to zero, and the small increments that you're then applying. And in terms of repeatability, in terms of if you want to repeat the deformation, for example, say you want to refine the grid and apply your deformation, or something like that. Then you would need to go through all the steps.
Yeah. Yes, that's true. Okay.
In my opinion, the way to do it is with respect to the initial every time. And if there's a problem with mesh quality, because the deformation is too large, for example, then the solution should be to apply the deformation in multiple steps. You apply it always with respect to the initial, but in multiple steps, which you can do with the nonlinear deformation iterations or something.
Okay. Yeah, that was also my concern. Well, does this mesh deformation sometimes break because we just impose too big steps? Because if every time we deform from the initial mesh, is it going to work every time? That's what I'm asking myself.
Probably not. Yeah, and we have this idea of having different right now we have a new kind of deformation solver that Ruben wrote based on the FEA solver, and the idea would be to kind of have a generic mesh solver, like a base class for mesh solvers, and we could then implement different methods. Because, for example, the elasticity based, I find that it fails a lot if you try to, for example, do a transformation that involves like shearing, a lot of shear in the structural sense. So, for example, if you try to put some sweep on a wing with mesh deformation, it kind of struggles a little bit and tends to distort things too much. And yeah. But it's we need more people writing code and opening pull requests.
Yeah, I mean, just one comment. I mean, Guillermo, who is here in the call, and Mladen, they are new people in our group. Yeah, just I don't know whether you already knew that or not.
Nope.
In case you were wondering who these people are.
Who's that guy? Who's that?
Yeah.
Great. Glad to have you. Please keep joining.
Thank you.
Hello. If you don't mind, I would have to ask something about this paranormal turbulence model. Yeah. So, it's okay if I address this question to you, or?
Yeah, I mean, I don't know if Tom, are you familiar with the implementation of the SA model?
Oh, for sure. Yeah.
Okay. So, when computing the production term on the source for the paranormal turbulence model, I don't see why. I don't understand why we do not take into account the 1 minus ft2 on the production. I mean, checking the code, it says the original SA model takes into account, but when it's computed, this factor 1 minus ft2 is not taken into account. So maybe you can bring some light into this.
Yeah. So do you know the? Oh, sorry, there's some background noise.
Yeah, it's under numerics, turbulent, tube sources.
I was actually gonna say, do you know the NASA turbulence modeling resource website?
Okay, sorry. Yeah.
So we follow for both SA and SST. We try our best to follow the different versions of the model that are listed there, and often that website has some really good information about all these little changes and why the terms are the way they are, or why they're left out. It's got a lot of great content. I'm actually trying to pull it up now to see if they say anything about that term, because we typically follow what they do there. So go to SA. Yeah, so for instance, you have a chat window, right? Like that page dropped in the, have you found that page? So, I mean, if you go through all these different versions, I don't know if it says something in here about that particular term, but just in general, I would check these pages because we try to go directly off of here if we can. So like we have the SA model, the SA negative model, and there's some other variants too. So now if I go code, let me look at what you're talking about. This one might be a long time ago, so let's see if I remember what we did there. This is reminding me also, this is kind of a side comment, but I'm digging through all of our new folder structure to get to different places. Are we still intent on, are we going to remove the other modules at the high level? And are we finished with our folder and file migration? Just a side question while I'm looking this up.
Nope.
Okay, because
what do you mean in particular? I mean there are still some files left. If that is what you mean.
Yeah, I think it would be good. I'm just, now that we have more levels, I find that when I'm going between like common and SU2 CFD, you know, I'm opening many folders to get down into other places. But anyway, we can talk about it.
What I don't like is that the headers and the CPP files are that far apart. that's very annoying. But
but you can do right-click open declaration, no?
Yeah, of course. Yeah. If you have IDE, it's not a big problem.
Yeah. So, Jeremy, I'm looking at the file right now. So you're talking about the base source term, right, for essay?
Yeah.
Yeah. So I do see we have actually a few things commented out. We have the production term commented out. We also have, well, there's some stuff for RE theta in there. And also just original destruction is commented out too. To be honest, I don't remember. I don't think I made these changes. I don't recall why they're commented out. I guess we can check. Well, it says, I don't think this is your doing. I think, Pedro, it says you were the one that changed it, but that's probably just because you moved the files around.
Yes, that is likely. I didn't change.
I think that's from the transition model, right? The guy who implemented the transition model there.
Yeah, that's actually a good find. So I don't know how we missed that. I wouldn't have recommended that we leave these things commented out in the source term. So it might be worth switching back to those versions of the source terms and running a check so we can rerun the NACA 012 and the flat plate and just verify that we are getting what we expect. So I think recently Giant had run some cases and was saying that he was seeing slightly different answers with SA. I wonder if this has something to do with it. Yeah, do you know, Guillermo, we have on the VMV page off the front of the website, we have the flat plate and the NACA 012 cases. It might be worth uncommenting these things and just rerunning those. I had done that a few months ago, but see how much of an impact these have. We might have to track down, just going back to the Git history when this changed, because it's, I don't think we want to leave things just commented out without a good reason. It doesn't make sense.
Well, I mean, it's not really commented out, right? I mean, it's just that it is in the else condition of the if statement.
Yeah, I mean, so I just...
But wrong, or in a different way.
Yeah, I like to have... I mean, I don't like to leave old code in there. So it's exactly for reasons like this. Like we have... Now we don't know why it changed, and it's just commented lines, which doesn't help anybody. So if there's a change, it's good to just get rid of the old code and actually make a comment about why you're doing what you're doing. But, well, that is what it is. So I guess, yeah, we should check. There's the paper also from the folks who did the transition model. I think we have a tutorial about this. I think there's a paper cited there. So we go to tutorial.
Or maybe it was Eduardo, actually. I can remember that he did some changes in the SA model at some point. Now we have to see.
Yeah, I have to dig back. I don't know.
Is it just because it's some revised version of the SA model and not like the originally published?
Yeah, might be something like that. Yeah.
Because there's the original turbulence model, and then there's the one that everyone else uses.
Yeah, I mean this is why I would say check the NASA turbulence modeling website to see if the new term is aligned with one of the variants. But even if that's true, I would recommend that we keep the baseline what it is, because people that run the code expect the baseline to be a certain thing. This is actually a very touchy subject in in the aeronautics world. I mean, you want to know exactly what variant of the turbulence model you're running because the results do change and people are very picky about it. So, I mean, I would suggest if we are going to make a change, which is perfectly fine, we actually name it appropriately and call it, give it its own option, or its own turbulence model option.
I think this is the Spallard-Amaras one equation model without the FT2 term, which is listed on this website.
Yeah, no FT2, probably.
Yeah, it's really called like that. One equation model without FT2 term.
Yeah, so I mean, that's why I'm saying that the people are very particular about this, and we should call it that because people will come back and say, my results aren't right. What's going on? And people like to use these different variants for different reasons. So we should be clear about that.
Yeah.
Yeah, I don't even recall when that happens, so we should maybe dig back through and try to find it. We could make two different, I mean, like we have for the other things, we have the different implementations for the different flavors of SA, so we could make a separate one for no FT2.
Yeah.
But
that means it's definitely
I
not.
hope that doesn't generate a new enum.
Yeah.
Well, yeah, I mean, unfortunately, I would love to have a better, well, the source terms, I've never really liked using the numerics for the source terms. I think it's just not as well done as sort of the convective and viscous numerics classes, because we have a lot of duplicate code here. I mean, this is like, at least for these cases, it's probably just a couple lines that are different. And this file is over 1,000 lines long. And we probably, between the different source terms, have like a handful of lines that are different. So it's not the most efficient thing.
Even the constants were duplicated everywhere. I then put a base for all the SA models to at least have the constants in common.
Yep. Yeah, that's good.
But then I stopped there because like you said, it's too much.
Yeah,
there was also something weird going on in that source term anyway. This is why the peer accumulation is commented out there, because it was not working at all. And I still don't know why.
That's never a good sign. See the pre-accumulation.
Yeah, exactly. That means that there's really something strange going on, but I never had really the motivation to look into that.
Yeah.
Well, probably just because something's missing, right?
Probably, yeah. Yeah, there must be some term that's dependent on something in there that isn't included. Okay, but I was going to say, Guillermo, I hope that helps answer your question. So if you want, we can divide this into two turbulence models, or you can, well, I'll leave it to you. I don't know what your intent is for working on it, but we can try to clean this up if you have some time.
Yeah, absolutely. It's answering my question, so thank you. For the moment, it's okay. Yeah, just it was quite strange for the first moment, but everything is clear right now.
Well, yeah, it's a good catch. I have to admit, I didn't even notice that had changed. So we should be more careful.
Mm-hmm.
Yeah. Okay, then I would say that's it for today. I don't know. Are there any other things?
No, I'm good. I got one pull request through. I'm good.
It's a good day.
Yeah, Tom, you can merge then yours if it's ready. I can also give my okay on that.
Yeah, I need to put in the Clang format file, which I'll do right after we hang up, and then I can merge it later today. Yeah.
I think this large mesh thing is also good to go, actually, right? Oh, you also approved it already.
Yeah, it's ready, but I think there's a conflict now, so we can ask.
There's a conflict?
Paul to fix it.
I mean,
I thought I saw that.
I mean, there are not that many changes, so the conflict should be, I don't know.
Oh yeah, it should be quick, but I thought I saw that it couldn't be merged, so I just.
Okay, this is what you mean.
Oh,
Admin fixed
maybe.
it. Admin fixed it already.
Yeah, it's fixed,
nice.
yeah.
Done. Okay, perfect. It was that's within the last 20 or 30 minutes. So.
Okay.
Okay,
Yeah, then
then that
this
one will
was
be
also
ready.
good to go. I mean, can also merge.
Yeah, I
that
think we
one.
can just do that next as soon as it's finished. Oh, that's fine.
Any issues with having the history of the linear solvers for the joint solvers, or?
Oh no, of course not. I mean, this is like that's
Yeah, it's
actually a
just
very
that
easy one.
we have it for the other stuff, so might as well.
Yeah.
Yeah.
I can
Sounds
also
good.
give my call later. Yeah. Okay on that. Okay.
So talk to you guys next week then.
Yeah. Okay. Perfect.
Sounds good.
Bye-bye.
Okay.
Bye-bye.
Bye, guys.
Bye.
Bye.